So
Want to take us through and describe it?
First of all, the smart meter story starts with a smart meter. So basically, this is an electric meter, but it's a digital electric meter that has a card in it. It's a radio transmitter.
It's a lot different than my meter.
Yeah, probably. Yours is no mechanical meter that
That's
spins
right.
around. This one doesn't spin,
Right.
but it communicates with the utility as many as 96 times a day, as opposed to the utility used to read it once a month. So hence big data. Who would have thought around you is all of this data? So
that's little data.
So the old meter was little data. This is big data.
Okay.
Yeah.
And so some examples of what we do with that, we have some samples in Google Earth. First of all, we deploy these in neighborhoods and in high-rises. On the demo here, you'll see a high-rise, and this high-rise is in Chicago. So we're going to tour downtown Chicago, flying by the Trump Tower, and you'll see two high-rises. This is 150 North Wacker. These buildings have meters scattered throughout the floors. The lines show you the RF signal that's propagating across the river, and then you'll see all of the meters in the building and the communications up through the center of the building. So this is a mesh. This gives the meter an opportunity to communicate whatever is the best path to send data back to the utility.
So it's making those optimization decisions
Constantly, second by second. Basically, you take out your old mechanical meter, you plug this meter in, and you hang and run. It discovers all its neighbors and automatically communicates back to the utility.
So you're saying the infrastructure is a take out the old, put in the new, and
pretty much. Now you do deploy what's called an access point around about 5,000 meters. That access point uses cellular backhaul.
Okay.
So an AT&T or a Verizon or a Sprint backhaul.
Okay, so once that access point is in place,
it's hang and run. So utilities can deploy thousands of these a day, go down a street or up a high-rise. The next thing we did is that once you have these meters in place, the utility can now be proactive as opposed to reactive, and so they can look at things like your voltage on a hot summer's day and see how the voltage is. So here we have a mesh of 130,000 meters over the city of Chicago on one of the hottest days of the year. And so the utility can now look at low spots in the grid caused by excessive use of air conditioners and be proactive and go out and fix the infrastructure before it causes problems with the customers. This will also help when electric vehicles are more prominent, because electric vehicles will be adding loads that are unexpected loads over time. So that plane there is basically the nominal voltage, and you see peaks and valleys based on where the voltage is high or low.
So that nominal voltage peak, it might indicate a threshold of potential problem.
Yeah, the lower voltage would indicate that there's excessive load in that particular area, or a problem in the grid that they didn't know about that they had to go out and fix.